for those people who haven't made it. So a few of us, Tim and Robert, did some shooting on the pier this weekend. I know, James, you said you did some on Seal Beach, and John, you did some in the backyard, a little bit of playing around. Cool. Well, I have here, let me share. I have my kind of raw information, if you will. Let me make this bigger for you guys. So I wrote it down very sloppily in my notebook, and so I put it a little darker on a piece of paper for you guys. So I'm just gonna explain what I wrote down here. I'm having weird sunspots with my window here. Ooh, okay. Anyways, so I have the time. So at 10:51:21, I had an index error of 0, and then I had an HS of 54 degrees, 59.2. And then at 11:53, so a little bit of an hour later, I got my index error and my HS again. And then I had LAN. And for LAN, I did a few sites because I wanted to make sure I got the highest possible number. So at 12:56, I got 69.33. At 12:57, I got 33.8. 12:58, I got 36. And at 12:59, I got 36.6. So that was my highest. And then anything I got after that was lower. So I didn't write it down. So this was my highest number at this time. So I consider that one the LAN that I'll use. I did write on here, I forgot to write. For LAN, I had an index error of 0.2 off. And then I had my last site at 13:56, index error of 0, and my sextant altitude. I had a DR position, so this is the position of the end of the pier. So hopefully tonight we'll get something close to that. And then I have my height of eye about 26 feet. It was 21 feet to the to where you're standing, and then call it 5 or 6 feet above that for your height of eye. So I'm going to use 26 as my height of eye. Any questions on the information that I collected on that day? Okay, so now I'm going to transfer this to my site reduction form for the sun. Let me refocus. Okay, so let's see if you can read it with pencil. We have August 16th. Okay, we can read that. Our body is the sun. Our DR was 36.4 north, 755.9 west. So I'm just starting at the top and filling in some information. So I am going to put, as this number is going to be my chronometer time. So, so then I can adjust it from there. So I had a chronometer time of 10:51:21. I had an index error of 0. So index error, I'm going to put 0. And then my HS, I'm going to put 54:59.2. So I'm just putting this information into column 1. And now I'm going to do that same thing with column 2. I have 11, 53, 24. I had 0.4 on, so I'm going to take it off by subtracting. And then I had a HS of 65 degrees, 03.8. Okay, and then I had my LAN was here at 12:59:30. I had an index error of 0.2 off. So if it's off, I'm going to put it on. I'm going to add it. And then I had an HS of 69 degrees, 36.6. Then my last one was 13:56:13. Index error was 0. And my HS was 65 degrees, 25.2. Okay. So now I have, oh, and then I'm going to write in my dip was 26 feet. Or my height of eye was 26 feet. So I'll just make a note there so I can write in my dip when that happens. And that's it for transferring my notes during the class, during the shooting to my site reduction form. So now on this, we go back to, I need to finish, this is our navigator section. And then this green is the almanac. And then our blue is 229. So I'll finish our almanac. We had a zone description. If I had about 10 o'clock, our zone description was +7 because of daylight savings time. So my approximate is 1700. So I'm going to say my GMT time was 17:51:21. Again, we have +7, +7, +7. So we have 18:53:24, 19:59:30, and 20:56:13. So now I have my GMT time, and these are all August 16th. So I didn't change dates at all. I'm still August 16th. So now I can go to August 16th. So let's see if I can do this here. Okay, so there we go. Oh, you can kind of see it. Maybe I'll do this. Trying to figure out a good way here. Okay, so for August 16th, our first time was 17:51. Can do this all day. Okay, so 1700, our GHA. On the top of the hour is 07358.0. Our declination is north 13 degrees 25.8. And my point, I am going to be decreasing as the days go by. So on my D area, I'm going to be subtracting. And my D at the bottom here is 0.8. So I can put that 0.8 here because it will be the same all the way across. So I got my GHA on the hour and my declination on the hour for 1700. Now I'm going to do 1800 because I'm at this page, so it's kind of a little bit of time consuming. So for 1800, I had 88 degrees, 58.1, and I had north 13, 25.0. Maybe I'll just do that. For my LAN, for my 1900 hour, I only need declination. I'm just going to write my declination one in at north 13, 24.2. And then my 20 hour, I have 118, 58.4, and a declination of 13, 23.4. Man, where is this sun coming from? My blinds are closed. Okay, so let's look at this together now. That I copied some information here. So I had my GHA on the hour, 1700, 1800, and 2000. And then I had declination at 17, 18, 19, and 20. And I know I'm subtracting by 0.8. So my next step is to go to the minutes and seconds. And I'm just going to go with these minutes and seconds, and I can add up my time. So my first seconds is 51:21. So I have 51. 21. I have 1250.3. So I'm going to do 12 degrees, 50.3. Okay, and then I have little d was 0.8. So I'm going to do 0.7. Oops, block that sun again. So now, is this confusing doing each one all together? I'm kind of thinking maybe if I do one both times, it'll replay itself in its head and you might get it a little more if I do each one individually, but I know I'm changing things up in the middle of things.
No, that's okay. I would like that repetitive if you would go through one column.
Okay.
And
Okay.
And little d was 0.7 or 0.9?
So it was 0.8, and then at 51, at at 51, little d was 0.7.
Oh, okay. I got it backwards. Yep. Okay. Sorry. Yep.
Yep. Okay.
Just found one of my errors.
There you go. Okay, we're going to do one at a time. I'm going to block B. Okay, that works. Okay. Okay, so our first shot was at 10:51. GMT was 17:51. We had our GHA on the hour. Then we're going to add our minutes and seconds. And I'm going to do a calculator so I know that it's right. 58 plus 50.3 minus 60 gives us 48.3, carrying a 1. So then we have 73 plus 1 plus 12 gives us 0.86. Okay. So now we have a GHA, and now we have to come up with our assumed longitude. So I want my LHA to be a whole degree. So that means, and I'm in the Western Hemisphere, so I'm going to be subtracting. So I know my assumed position is going to end in 48.3, so that it equals 0 down here at the bottom in the minutes column. So my DR latitude is 11759.9. So which number would be closest to the 48.3? It would still be 117. 48.3 is within 30 degrees of this longitude. So now I can apply this 0.86 minus 117. So I have 8.6. I have to add 360 to that so I can subtract it. Minus 117 gives me a LHA of 329 degrees. So that's what we go into our almanac or our Pub 229 with. So we have an assumed or a LHA. Then moving down the list here, we have declination. We have 13 degrees, 25.8. I'm going to be minusing the 0.7. So I have 25.1, 13 degrees north. Try not to get so sloppy here. And then my next step is assumed latitude. So I want to get the latitude that this is closest to. So we have 33, 36. So I'm going to say my assumed latitude is 34 degrees north. If you say 33 or you make this assumed longitude 18 or 16, does not matter. You're just going to get a larger intercept. So it kind of takes that into account. So it's okay if you assume one way or the other. Okay, so that is what we got from the daily pages. And now we have our information to go into Pub 229. But before we're done with the almanac, we have to convert our HS to our HO. So we have to do our correcting our sextant altitude to our observed altitude. So my index error was 0. My dip was 26. So we're going to go to our dip table. And I have 26 point a little, maybe 26 too. Where's 26? So 26 and 27, I'm going to say I'm a little over 26. So my dip is going to be 0.5. So 5.0, excuse me. 5.0 was my dip. So I have 59.2 minus plus nothing, and then minus 5. So I have 54.2, 54 degrees. I go back to my table here. On the sun, we are in April to September, and I observed the lower limb. So I'm going to go with my HA, my apparent altitude was 54. So I'm going to go down at the bottom here, 52 and 56. So I have a correction of plus 15.3. So then I can get an HO of 0.5. There's 9, and that's 6, so that would be 0. I'm going to carry a 1, and I have 55 degrees, 09.5 minutes as my HO. Are you guys with me so far?
Yes.
Great. Okay, so now for HC, this whole section, let me move it up here. This whole section we do in 229. In our 229. Site reduction tables, 30 to 45. So HC. So the three things we go into this book is our assumed latitude, LHA, and declination. Those are the three things that bring us to the right page in this book. So I'm going to be in the first half of the book so that I have a 34-degree latitude. And then I'm going to find an LHA that is 329. Actually pretty close there. So I have an LHA of 329 and a 34 degrees for latitude. And then I have all of the declinations. So now I need to decide, am I latitude same as declination? Or am I latitude contrary to declination? If I look at my two things, I have a declination that is north and a latitude that is north. So I am going to be same. This guy. Okay, so my declination was 1325.8. So I'm going to find 13 and 14. Okay. So you can read this. Okay, so we are going to be in between these two numbers right here. So at 13, so I have my declination, or my latitude, my LHA, and my declination was in between 13 and 14. So this is where I'm going to write in we can see this, right? So for my HC, I had 54 degrees, 54.3. And then I had a D. So here's the D. I have a D of 39.8. So I have a plus 39.8. I'm gonna write real small here. I need to interpolate this. So I'm going to multiply by the fraction of my declination. So in order to go from 13, where's my declination? My declination was 1325.1. So I'm 25.1 minutes towards that 14. So I'm 25.1 divided by 60 times my 39.8. Jeez. Okay. Moving this back up. So I have 25.1 divided by 60 gives me about 0.4, which would make sense. And then I'm going to multiply that by my 39.8. And I get a plus 16.6. So I'm going to do 54.3 plus 16.6. Gives me 10.9, and I carry the 1, so I have 55 degrees, 10.9. Any questions on how I calculated my HC? Okay. So now I'm just going to move my HO. It was up here. I'm just going to move it down here so I can get what my intercept is. So I had 55 degrees, 09.5, very close. So 10.9 minus 9.5 gives me 1.4, and then I do my HO. Is HO more than? No, so it is not towards. That means it would be away. So I have 1.4 away. 1.4 is going to be very small. But that's okay. Any questions on that? So we got our intercept. Okay, so back to...
The key is just pulling that fraction off the declination. So you're basically tweaking declination when you get to that D, when you're interpolating.
Right here?
Yeah.
Yes, so
Yep.
It was, 13. On our declinations, we had 13. We got what our HC was.
Right.
And then at 14, we got what our HC is.
Right.
And we know we're 25.1/60ths of away in between those two.
Okay,
So
cool.
yeah, it is just that fraction of what's left over in our minute section.
Mm-hmm.
Okay. So back to it this way. Our Z and our ZN. So Z is in this column, and we're going to put our Z and then our next Z. So I'm going to write it in here so we can see it. Our Z is 119.2, and our next Z is 117.9. So those are our, so this was at 13 and this was at 14. So again, we are 20/60ths in between these two. So they don't give us the difference. We have to calculate that difference. So we have 19.2 minus 7.9 gives us a difference, and we are subtracting of minus 1.3. And then we're going to multiply that by our 25.1/60. 25.1, it was 0.4 something. 0.4 times 1.3. We are subtracting 0.5. So our correction will be subtracting 0.5. So we're going to subtract that from our original, from our 13. So 13, or not 13, 119.2 minus 0.5 gives us 118.7 degrees. So that is our Z. And then we follow on this page and on every page a little rule at the top to go from Z to ZN because we want our ZN. If LHA is greater than 180 or less than 180. So our LHA was 329, so it was greater than 180. So our ZN is equal to our Z. So our ZN is 118.7. And then the last little thing on here is advance or retard. So if I wanted to make a 12 o'clock position, I wanted all of these to noon. So I'd have a nice clean noon position. I would do 60 D Street. So I'd have about 2 hours and 9 minutes. No, 1 hour and 9 minutes. So 69 minutes times my speed in order to get my distance that I would have advanced or subtracted. We're doing 0 as our speed, so we don't have any advancing or retarding. But say you're like, oh, I traveled, 8.2 nautical miles. So then when I'm plotting my assumed position, it's easy for me just to advance something that I already have my 60 D Street done. So this column here is your 60 D Street. But for us, it's 0. Erase that 8.2 so it's not confusing. Any questions so far on this guide?
I just wanted to confirm that the 1.4 away, that's away from the sun, right?
That's away from this azimuth.
Yeah. Okay.
Yes, away from the sun, because this azimuth is pointing to the geographic position of the sun.
Sun, yeah. That's kind of how I have it in my head. Yeah.
Mm-hmm.
Okay.
Okay, let's do the next one. Okay, so still there. Where are we at? So we're go to our August 16th. Our GHA for our 1800 we wrote in, and our declination we wrote in with a minus and a little d of 0.8. So we already did that part, and now we're going to go to the back for our minutes and seconds. $53.24. So here's our 53.24. So 53 minutes, 24 seconds. Under the sun, we have 13:21.0. And then for our little d was 0.8. Again, we're at the 53. So our correction is 0.7. So now I'm going to add up. I have 58.1 plus 21 minus 60 gives me 19.1. I'm going to add a minute, so I have 88 plus 1 plus 13 gives me 102. So my GHA of the sun is 102. 19.1. I'm going to come up with an assumed longitude so that my LHA equals 0 or has 0 minutes. It's a whole degree. So my minutes are going to equal 19.1. So now I want to decide, is my assumed longitude within 30 minutes of this number? So I'm going to go 55.9 plus 30 minus 60 gives me 25. So yes, if I do 118 degrees, I'm going to be within 30 minutes of this assumed longitude. So I have 118.191 as my assumed longitude. And now I need to subtract. So I have 102 plus 360 minus 118 gives me 344 is my LHA. All right. Then I'm going to apply my correction for declination. I'm minusing this 0.7. So I have 24.3, and this was 13 north. My latitude, assumed latitude, is going to be 34 degrees. I'm just rounding that up. And I'm going to be same. So if you are, you know, moving north or south pretty quickly, and your hours are, or your sites are at different hours, you could have, you know, different assumed latitudes here. If you know, were closer to 35 or you were closer to 33 or something at a different time. So that's why we have a space for our DR latitude at each site, even though they didn't change for us. That makes sense. Okay. So we did the first part of our nautical almanac. The second part of our almanac is correcting our HS to HO. So we had an index error that I got from my site of -4. My dip is the same. So I have -5.0. So let's do that math. -4 -5 gives me 64 degrees, 58.4. So I have my HA of 6458.4. I go to my A2 correction to correct for refraction, and I have 64 is going to be oh, I don't know why that number is circled. Okay. Sorry. 6458. So 6458 is going to be in between 61 and 67. So I have a plus 15.5. So I had 54.4 plus 15.5 60 gives me 13.9, 65 degrees. So I have an HO. Any questions on HS to HO? You guys are doing all right? Okay. So now we get to go to Pub 229. And again, we need our, I'm going to do a different color. How about that? That's fun. LHA, declination, and latitude. So we have 344 is the number we are trying to get at. So we were at 329, 344 is our LHA. Our assumed latitude is 34. And our declination was, again, in between 13 and 14. So we're in the same little spot there, or not the same because we're on a different page, but right in between 13 and 14. So we're in between these numbers. I'm going to write those numbers so you guys can see them. So my HC for the 13 even was 64 degrees, 27.6, and I had a D correction of plus 50.6. And so that in order to interpolate here, I'm going to multiply by what's left of my declination. So I have 13 degrees, 24.3. So I'm going to do 24.3 60ths multiplied by the 50.6. Four times 50.6 gives us a correction of plus 20.5. So I'm going to do my 27.6 plus 20.5, and I get 48.1. So that's 64 degrees, 48.1. And then my next line here is HO. So I'm just moving this HO down here. So I have 65, 13.9. So this is where my HO comes into play. Which one is bigger? HO more than, it's towards. So HO. And our 65 is going to be bigger than our 64. So we are going to be towards. And then we need to calculate the difference here. So we have 13.9, 13.9 plus 60 minus 48.1 gives us 25.8. So we have 25.8 towards as our intercept. This little indication, this one was very small, 1.4, this one 25, does not indicate on a worse or lesser quality of a site. It's just further or closer to the assumed position, which again doesn't really mean that's where we are. So don't look at, if your number is large, don't look at it as, oh my God, I'm in Mexico or something. Doesn't mean that. Okay. Any questions with our intercept? Does that make sense? Okay. Let's do our Z and Zn. So I'll write the numbers here so we can see them. We had 1 for 1.5 and 1 for 0.2. Okay, so again, this was our 13 declination and this was 14 declination. So we want to calculate the difference so we can see what our 1324.3 would be. So it's our interpolation. So we had 0.5 minus 40.2 gives us a correction of minus 1.3. And we're going to multiply by our 24.3 60ths. 24.3 divided by 60 times 1.3, we get minus 0.5. And we get a Z of 141.0. Then we need to convert our Z to Zn. So we have our rule here. Is our LHA less than or greater than 180? It was greater than. So our Zn is equal to Z. And we have no advanced retard. All right, any questions on that one? All right, good. Now we're gonna do the shortcut one. It's gonna be super quick. I can move my jump around. Okay, so this is our LAN. I already kind of put out the site reduction form for it, but I did that from my head. Maybe I'll make, yeah, I'm gonna make one. I'll make a LAN site reduction form. That way you guys can try it out. Okay, so I don't have to do any of the GHA, assumed longitude, any of that stuff. For declination, I had 0.8, and so I need to get my 5930 in my minutes and seconds to see how much of this 0.8 I'm going to use. I'm going to tell you right now it's going to be the full 0.8 because I'm at 5930. So let's just do it. All right, 59.8. We have our 0.8, which makes sense. So we have 24.2 minus 0.8 gives us, watch out, 23.4, 13 degrees north. So we have our declination. So the two things we need for latitude by LAN is another highlighter here. Our declination and our HO, which gives us ZD. So that's a little dark. We need to calculate our HS to HO. So that's still in our nautical almanac. We had our HS, that was what we saw. Our index error was what I saw right before or after I shot. And then I have my dip shot in the same place. So I have minus 0.5. When would your dip be different? Any guesses?
Take the sight off the stern versus up at the mast. I mean, you got a couple feet there.
Yeah, you took it in a different place on your vessel. Maybe you were down low on the stern, or you were up on the flying bridge, or wherever you were. So it might be a good idea if you were, on the same vessel. You can say, oh, the flying bridge has a height of eye of 25 feet. The stern has a height of eye of 15 feet. If I'm up on the bow, it's a height of eye of 18 feet or whatever. So that way, it's an easy go-to. Okay, so my height of eye, I have 13.6 plus 0.2 minus 5 gives me a 69, 31.8. I go to my altitude correction page, 69 is going to be in between my 67 and 73. So I have plus 15.6. Plus 15.6 gives me 47.4, 69 degrees, 47.4. So I have the two things that I need, well, almost. Now I need to convert my HO to ZD. So here you are in your boat. There's the sun. So the angle from the horizon to the sun was your HO. That's your altitude. And then from zenith, directly above you to the sun is your zenith distance, your ZD. So that's a 90-degree angle. So 90 minus your HO, you get ZD. So we do 90 minus HO gives us ZD. So I'll do 8960, that's 90, minus 69, 47.4. I'm going to do this on the calculator. 60 minus 47.4 gives me 12.6 and 20 degrees, 12.6. So now I need to decide if I'm adding or subtracting this ZD and my declination. So the declination was 13 degrees. That's where the sun is. And if I'm in Newport, I'm above, so wait, I didn't write this down. So from the equator to the sun is declination. That's a D. And if I'm in Newport, I know I'm above 13 degrees north. So I'm going to say above that is me, and that is my latitude, somewhere above the sun. And then from the sun to me, that is my zenith distance. So from this, I can say zenith distance plus declination equals latitude, just from drawing in that little picture there. And if you don't know, you could add them, see what number you get, subtract them, see what number you get, and whatever number is closer to your latitude is probably the right method. Okay, so my ZD was 12.6. My declination was 23.4. Gonna have to do this. 12.6 plus 23.4 gives us 36.0 and 33 degrees, 36.0, which is going to be pretty close to our DR. Our DR is 36.4, so about 4 miles off, not bad.
Well done.
So that is how we got our latitude. So I'll show you when we get to our maneuvering board how we're gonna plot all of this. But we didn't have to go to pub 229 at all. That was our shortcut. Make sense? All right. Okay, I don't have to have that there anymore. Sun is going down. Okay, so we got our last column here. Almost ready to plot. Our last column was at GMT 2056.13. We got our GHA, we got our declination, we got our HS. So we go to the almanac for the minutes, looking for 56.13. There we go. $56.13 for the sun. I get 1403.3. If I get 14 degrees 03.3. And then my little d was 0.8. And I have 0.8 as my correction. So I'm done with that book for now. Okay, so for GHA of the hour, 11858.4 minutes and seconds to get me GHA of our time. So .4 plus 3.3 gives me 01.7. 1.8 plus 1 plus 14 gives me 133. So I have 133 degrees 01.7. For my assumed position, or my assumed longitude, I'm going to be subtracting. So I know I'm going to end in 01.7. So I'm going to decide this is my DR longitude still. So I'm going to say 11801.7 is going to be within 30 minutes of this. So I'm going to say 118. That's going to be my assumed longitude. And now I can apply 133 minus 118 gives me 15 degrees even. So an LHA of 15 degrees. For my declination, I have 23.4 minus 0.8 gives me 22.6, 13, and that is north. And my assumed latitude is going to be north, 34 degrees, same as the other ones. So we have our LHA, our declination, and our latitude. Those three things that we need to go to Pub 229. But before we're done with Pub, with the Nautical Almanac, we have to convert our HS to our HO. So I wrote in my HS. I had 0 for my index error. dip is going to be minus 5.0. So I get 65 degrees, 20.2 as my apparent altitude. So I can go to 65 on this guy. It's going to be in between 61 and 67, so I have 15.5. So I have 20.2 plus 15.5 gives me 35.7, 65, 35.7. So that is my HO. Now I can go to Pub 229. Is the HS to HO making sense? I know I'm doing it quickly, but it's okay? Okay. So Pub 229, we are looking for 15 degrees this time. And it's going to be at the beginning. So we are at 15 degrees for our LHA. We have a latitude of 34. Okay, I'm just going to write it in here. And we're, again, in between the 13 and 14. So we're going to be right in between those numbers. I'm going to write it in so we can read it. Woo. .0 plus 61.4. Okay, so I had 64.58, and then my little d, which is how much I can get to the 14, is 51.4. So I need to make this the remainder of my declination into a fraction. So multiplied by 22.6 60ths gives me a plus, we'll call it 19.4. I'll round it up there. So 58 plus 19.4 gives me 65 degrees, 17.4 minutes. And then I'm going to move my HO right down here, just copying it there. And I get 65 degrees, 35.7. So I do my HO. My HO is bigger than my HC, so I'm going to be going towards. And by how much? So I'm going to do 35.7 minus 17.4 gives me 18.3 nautical miles towards. So from my assumed position, I'm going 18.3 nautical miles towards the sun. Okay, so that was our intercept. And now we're going to do our Z to ZN. I'll write these numbers in so we can read them. Okay. So at 13, this was at 14. We had 143.4, and then we are subtracting some amount. And I'm going to figure that amount out. 143.4 minus 1.2. So we need to interpolate by multiplying these 22.6. That's the leftover minutes in our declination. So multiply by 22/60 divided by 60 times 1.2. 0.45, I'll round that to 0.5. And we apply that to our 13, because we're going from 13 down. So 143.4 minus 0.5 gives us, write this big, 142.9 degrees. So that is our Z. And now we need to convert to Zn. We have this time an LHA less than 180. Our LHA was 15. So we're going to do 360 minus Z to get our Zn. So this is 360 minus Z gives us our Zn. So 360 minus 142.9 gives us a Zn of 217.1 degrees. And we don't have any advancing or retarding. So wow, that was a whole heck of a lot of work, wasn't it? So now we have our information that we can plot.
So again, if you're doing a running fix, basically you're just advancing that Zn by your speed, basically, in your course.
Yes, and I'll show that to you on the plotting sheet.
Okay, if we were going to
advance it.
Okay, cool.
Okay, so for the plotting sheet, we need the assumed position, the intercept, and the Zn. So we need, I'm going to highlight the assumed position. So that's our assumed latitude, our assumed longitude, our intercepts, and our Zns. So those are the ones that we need. But first, we have to set up our plotting sheet. All right. So let's call, we have 34 is our assumed latitude for all of these. So I'm going to call 34 our mid-lat. 34 degrees. There we go. So I'm going to make this 35 and this 33. I'm going to make my mid-longitude, I'm going to make our mid-longitude 118 degrees. So I have 117, and we'll make our way over there. So if I have a mid-lat of 34, I'm going to use my sharpen my pencil a little bit. Okay. So we have 30 degrees, 35, we're just shy of that 35. call that 34 degrees. Okay, so I have 60 minutes of longitude here, 60 minutes of longitude here, 60 minutes of longitude, and 60 minutes of longitude. Get my triangle out, draw in my longitude lines. Okay, so I have, this is 118, this will be 117, 116, 119, 120. Okay, so now I have my basic plotting sheet. Don't have an eraser, so you're not going to make mistakes. Cool. Okay, so I've set up my plotting sheet. Any questions on the plotting sheet? I know I did that pretty quickly. All right, okay. So now I'm just gonna start off with my first one. We'll do the whole LOP, and then I'll do the second, third, and fourth. So we'll do one at a time here. So I have a assumed position of 34, so I'm gonna be somewhere on the 34 line. And then I have assumed longitude of 117, 48.3. So I am gonna get down here, 48. I'm gonna get 48.3. So I'm gonna put a marker on the 40. So this is the 40 number. And then I'm gonna do 48. Is right here, plus just a little bit. We'll call that 48.3. So let me go back here. We're at 117, 48.3 on 34 degrees north. So this is going to be my assumed position. So I did that, and now my next step is to plot my intercept and my ZN. So my ZN was 118.7, and then an intercept of 1.4 away. So 118.7, I'm going to get my triangle. 118, so we have 120, 150, 118.7, almost 119. 8.7, we'll call that 118.7. And then I can parallel this to wherever I want it. So I'm going to go away, so this direction is 118, away would be that direction. So I'm only going by a little tiny bit. So I'll draw a little line, and then I'm just gonna put a little dashed line. So that is my away from 117, or 118.7, excuse me. Then, I don't even think I can, my intercept was 1.4 away. So mine don't go smaller than that. So I'm eyeballing it here. We'll be all right. So right about there, we make a perpendicular line. So now I'm going to draw in my line. And that is my LOP for 1051. So you can see why I drew in, I knew I had a small intercept, but I drew this dashed line in, so I'd have something to take that perpendicular line off of. I wish I had an eraser where I could erase it now. I do not. Is what it is. Okay. Any questions on our first LOP? Oh, I wanted to say, okay, so if I was moving, let's say I had a position here at 0800 and I'm moving along this way. So if I had, I needed to move this, advance this by 8 nautical miles or something, I had my position with my course and my speed, and I needed to move it 8 nautical miles, I would find 8 nautical miles and then parallel, so I'd advance my line to my new line. Dot, 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 dot. I'm drawing lightly so I could try to erase. So then I would call this 10:51 to 12 o'clock. And that would be my LOP, not this line. But we're not moving, so we don't have to do that. Okay. Okay, now we're going to do our next one. Assume position 34 degrees. I'm at 118.19.1. So I'm going to find 19. I'm going to do the 10 and then in between ends here, 19.1. And I'm at 19.1. So this is my assumed position. So I've plotted my assumed position. Now I need to do my ZN and intercept. So I'm doing 114 towards, and that's 25.8. So 114 I'm looking for, 141. 141. Okay. And I'm going towards 141. So towards 141. There's my azimuth. And now I'm going to get my intercept, which was 25.8 nautical miles. So I'll find 25.8. So here's 10, 25, and a little bit. So I'll put that here. Of course, I don't have it exactly, but okay. So now I will draw in my LOP. So I have an LOP here at 11:53. Any questions on that one? All right. So I have two LOPs. I could call this a position, but I have two more LOPs. So hopefully we'll get some sort of triangle or parallelogram or something. I can already see that these are crossing in the 118 section, and I know I'm in 117, so I'm a little bit off, but that's all right. We'll see by how much. So our next one to make a triangle is going to be super easy. We have a latitude of 33 degrees, 36.0. That was our LAN. So I'm going to find 33 degrees. So here's our 33. And then 36. Right there. So I'm going to, actually this is making quite the pinwheel here. So this was my LAN at 12:59. So at this point, I have a pretty good idea of where I am, which is not where I thought I was, according to Google or wherever I got that assumed position. Makes me want to go back and double check it. Okay, any questions on the LAN? So we just used that latitude as an LOP. We just mark in the latitude and it's super easy.
By the way, Bree, I did go ahead and do a full reduction on the LAN.
Mm-hmm.
And I wound up with a zenith direction of 182.8 degrees. So it was
okay.
almost vertical.
Yep.
And then the
LOP would be
horizontal, or
would be horizontal.
Almost horizontal.
Yep.
However, what, at least in my case, the LAN latitude position was actually more accurate than the plotted position. So
Okay.
I don't know if it would always be that way, but it was for me.
I don't know if it would always be that way. I don't know, but okay. Okay, so now we're going to plot our last one. We have a position, assumed position 34 degrees, same. A assumed longitude of 118.01.7. So again, we are going very, very small. 1.7. Mine's not even gonna go that close, but I'm gonna try. We'll just mark it right here and call that my assumed position. So I was at 118.01.7, so I'm very, very close to that 118. And then I have my ZN and my intercept. So my ZN was 217, and I'm going towards by 18. So let's find 217. 217, yeah, almost 220. 217. There's our 217. And then we're going towards 217. So here's towards. And then I'm going towards by 18.3. So I'm going to find 18.3, 19. That's 18.3. Right. And now I can get an LOP. Why is this one? I did that off the wrong, I was like, that's not making any sense. I did it off the wrong assumed position. Okay. $18.3 from this assumed position. That makes more sense. Do our right angle. So this was our 1356 LOP. So we have somewhat of a triangle here. Not too bad. My DR that I thought we were at is, okay, that's 34, was 55.9. So let's find 66. Okay. So that's where I thought I was. So maybe I might say this one's a little bit off. It could have gotten us closer. There it is. If I had a little bit different from this one, I would say this one's pretty good, and maybe a little bit different on that guy. Where is he? Here he is. Yeah. All right, so if I wanted a really good one, I was off on my two morning shots. Just by a little bit though. Somewhere in the ballpark. What do you guys think?
Way better than I got.
So what was yours?
Well, I wound up in San Clemente. So I
Okay.
was a diagonal distance. It was about 17 nautical miles off.
Okay, well, 17 isn't that bad.
Yeah.
If you're in open water, that's real good.
Yeah, okay. It's
So,
almost a Catalina.
well, next weekend, we're going to do the stars. So on this one, as you could tell, it was the same kind of numbers repeated themselves, right? We were always between 13 and 14 for our declination. So our little d's were pretty close. Our differences in the z's were always pretty close. The declinations were always pretty close. So this, when you do the sun over and over again, your numbers will look similar. They're not going to be exactly the same, obviously, but they will, you know, be in the ballpark similar to each other. Where when we do the stars, we're going to have some stars northern hemisphere declination, some stars southern hemisphere declination. It's going to be a lot more different numbers, so it won't be as predictable. Like if I opened up my Pub 229 and I got, you know, 030 or something for my HC, I would be like, whoa, it's supposed to be, you know, somewhere in the 60s, or, you know, if it's really far off from my other ones, then it might be a red flag. Where the stars don't have that. The stars have their own little challenges. They're harder to see because they're a lot smaller than the sun. So when you go out there and shoot the sun, you're always going to know where the sun is, and it's not going to be mistaken for the moon. That's the good part about doing the sun. So I'm glad you guys did it. And yeah.
So I have a question about the star sites.
Yes.
I'm having trouble, so I'm just going out in the backyard and looking at the stars, and I'm having trouble to actually discern which star is the one that I'm trying to shoot. So is there any tricks to that? Or?
So my go-to trick for that is use Pub 249. So
Okay.
have it in your sextant altitude already. So the sun, we pointed 0 at, and then floated our way down. For the stars, I don't do it like that. I already have the pre-calculated altitude in the sextant.
Okay.
And then I look around in that general area. So in your backyard, know which way's north. So if you had a bearing of, you know, 045 or something, you could put your sextant looking through it in the direction of 045, give or take 10 degrees, right? And then you have your altitude already set. So if you kind of just do these little circles and you finally see a star, that's the one you want to use. So that's my trick. If you know the star by a constellation, so you see the star by a constellation and you do the little float thing down, it is so easy to somewhere in between lose the star in the mirror, and then you pick up another star, and then you're like, oh, that's the star, right on. And it's completely not.
Yeah, great.
So you'll get better at that, though. If you do, both ways work. So if you do the floating one with the star, it gets easier and easier, but there will be some side. That's why I say take 5 or 5, 6, 7 stars, because one of them you might have lost it and then picked up the wrong star and your number is completely out of whack.
Right.
And so you're like, oh, scratch that one. I have 7 more I can choose from. So
Okay.
the more you get, the better. But we're in that twilight window of stars and horizon. What can we see?
Right. Yeah. Okay.
So yeah, good. All right. Well, that's all I got for you guys tonight. I will scan both of these and put up there on the Google Classroom. And other than that, I will see you guys Saturday and Sunday.
Yeah, when is that again? 7:30?
7 o'clock, I'll be there. So sunset is about 7:30.
Okay.
So again, give time for parking.
Yeah, yes. And it's the weekend, so
And it's the weekend.
it'll be worse.
Yeah,
Okay.
so my goal is to be there about 7. Sunset's about 7:30 or twilight about 7:30. And then we'll shoot. And when we're done, we'll leave. So
All right.
that's it.
Sounds good.
All
Thanks,
right.
All right.
Well,
See
you guys
this
have a
weekend.
good week. Stay cool.
Yeah.
All right. Bye-bye.
Thanks, Bree.
Bye.
Thanks.